So we've talked in class about solving systems of equations before, and you've talked about them in Algebra 1 and Algebra 2, so now I'm going to talk about how you solve a nonlinear system. And the idea behind this is that you have to look at this and say, I got to solve something for one variable, and I got to look at this and say, what's going to be the easiest to solve for? And if you look at this system, you might say, I don't know what the easiest to solve for is. I don't even know where to start. Well, what my suggestion is usually going to be is that there's probably going to be something, a variable somewhere where it's going to be easier to solve for than anything else. And I would say that if you look at this, you probably look at this and say, I could probably just very quickly solve for y by moving this to the other side and then adding 1 to the other side. I don't know why it's doing this. Anyway, if you add this 1 to the other side, you get y equals (2x plus 1). So what we need to do is we need to plug this back into the first equation. So what you're going to get is 3x squared plus 4x minus y, which is 2x plus 1, equals 7. So now what we do is we have an equation that's a quadratic. So I have 3x squared plus 4x minus 2x minus 1 equals 7. So I solve this equal to 0. And I get 3x squared plus 2x minus 8 equals 0. Now you might say, well, now what do I do from here? Well, you might want to look at this and say, is this factorable? Well, can I find numbers that multiply to negative 24 and add to 2? And the answer for that would be yes. So this is factorable. We can find numbers that multiply to negative 24 and add to 2, and that would be a 6 and a negative 4. Those add to 2 and multiply to negative 24. So these have a negative 4 in common. These have a 3. These have a 2x in common. These have a 2 in common. These have an x. So what you're left with is 3x minus 4. You're left with 3x minus 4 times x plus 2. And I set that equal to 0. So I have two answers for x. I have x could be 4/3. I have x could equal negative 2. And that's how you solve a quadratic. However, the difference between this and how you solve a normal quadratic is that now we have to figure out y's. And for a picture of what this looks like, we have a parabola and we have a line. And from a graphical standpoint, we're looking for where these two lines meet. So they meet here and here. So the question is, where are those 2 points? Well, we just found the 2x coordinates. We found 4/3. So now we need to find the y coordinate. So we plug that in. And we also found negative 2. So we got to plug that in as well. So I got to plug both of those points in. If I plug in negative 2, what I'm going to get back is a negative 3. So that's one ordered pair. That's a solution. If I plug in 4/3, I'm going to get 8/3 plus 1. That's going to be 11/3. So I have two ordered pairs that are solutions to this. So let's take a look at this next one. Again, it doesn't make sense to try and figure out what's the best one. I'm just going to take a look at the linear one and solve that by moving the x over. So I get y equals 4 plus x. So I'm going to replace that in the second equation. So I get x squared plus 4 plus x equals 3. So I'm going to just switch everything around and minus the 3 over to the other side. So I get x squared plus x plus 1 equals 0. Now, this is not factorable anymore because you can't multiply something to get 1 and add to get 1. So you're going to have to use the quadratic formula. So I get x equals negative 1 plus or minus the square root of b squared, which is 1, minus 4 times 1 times 1 all over 2 times a. So I get negative 1 plus or minus the square root of 1 minus 4, or a negative 3 over 2. So you might get to this point and say, well, that's the square root of 3i. How is that even going to be plugged? Can that even work for this? And the answer is no. If you have a parabola or some graph, we're looking for real number solutions. So these are imaginary numbers. And this won't produce imaginary numbers. So there is no solution for this. But if this were to produce two different numbers, we'd have to plug it back into what we solved for, which was this, to find the answers. So I'm going to look at this next problem. It says a shoe company invested $300,000 to purchase a new line of athletic footwear. Each pair of shoes costs $5 to produce and is sold for $60. Okay, so how many pairs must be sold before the business breaks even? So we have to look at this in terms of the revenue they make and the cost to make the shoes. Well, the cost is $5 per shoe. So we know it costs $5 plus an amount per shoe. In addition, you had to pay for the store or the company, the investment. You have to pay for this initial investment for them to make the new shoes. So this is what it costs per X shoes. That's a model for any number of X shoes. It's going to cost this much money. The revenue you get is for selling the shoes at a higher cost for the customers. You sell them for $60 per the amount of shoes you sell. So the question is, how do you break even? Well, you break even when your cost and your revenue are equal. So that's when these two things are equal to each other. So the way you would say that is, well, where does this equal cost? And after you sell more than that amount of shoes, then you start to get into profit. So after you break even, then beyond that you get into profit. So this is now an equation that you can solve for in terms of cost and revenue. These are two equations. You set them equal to each other, and this is your break-even point. So you solve it, you get 55x equals 300,000, and then you solve that from there. You divide 300,000 by 55, and you get your answer.